Yes, students. Now one question is asked based on catenation. This carbon and silicon, they both have same valence electronic configuration. Like carbon, what is atomic number? 6. Silicon, what is atomic number? 14. So what is configuration of electronic configuration of carbon? 2, 4. Outermost how many electron? 4. Outermost electron is called valence electron. And silicon, what is atomic number? 14. So protons 14, electrons 14. Distribute that 14 electrons in different shells, that will be the electronic configuration. So 2, 8, 4. So outermost how many? 4 electron. So both carbon and silicon, their valence electrons are same. They have similar valence electronic configuration. Electron in the outermost shell is same. They have unique electronic configuration. And both show the property of catenation, self-linking. Carbon, self-linking property of carbon atoms to form long straight chain or branch chain or rings of different size, that is called catenation. So carbon also shows the property of catenation, but carbon can, how many carbon atoms can self-link with it? With itself, about 100 carbon atoms. Carbon, it forms compound with hydrogen, which is called hydrocarbon. Compounds of carbon and hydrogen is called hydrocarbon. There, how many carbon atoms can self-link with itself? About 100, around 100 carbon atoms. So the property of catenation, carbon shows to a larger extent than silicon. Silicon also has 4 electrons in its valence shell, outermost shell. But how many? Silicon also forms compounds with hydrogen, which is called silanes. And there, how many silicon atoms can self-link with itself? Around 8 to 9 only. And carbon, how many can self-link with itself and form the compound hydrocarbon? 100. So why carbon shows the property of catenation to a large extent than silicon? Silicon also can self-link with it. But how many silicon atoms? 8 to 9. But carbon, around 100 carbon atoms can self-link with it. So carbon shows the property of catenation to a large extent than silicon. Why? So you look to the size of carbon and hydrogen, silicon. Carbon, how many shells? 1, 2. Electrons are filled in 2 shells. Center nucleus, how many shells? 2. So size of carbon is small. And silicon, how many shells? 3. In 3 shells electrons are filled. So size of silicon is larger. And now because of small size of carbon, the shared pair of electrons between 2 carbon atoms, when electrons are shared, what type of bonding is formed? Single covalent bond. And this shared pair of electron between 2 carbon atoms are held strongly. Carbon can hold the shared pair of electrons strongly. Why? Because of its small size. So the bond which it forms with other carbon atom, that single covalent bond, is very strong, making this compound of carbon exceptionally stable. So carbon shows the property of catenation to a larger extent than silicon. Silicon size is larger. So the shared pair of electron will be less strongly held by the nucleus of silicon. So the bond which it forms with the other silicon atom is not much stronger as compared to carbon. So carbon-carbon bonds are stronger than silicon-silicon bonds. So the property of catenation, carbon shows to a large extent. Why? Because of its small size. Because of its small size, the carbon-carbon bond is stronger than silicon-silicon bond. Okay. So why both carbon and silicon have similar valence electronic configuration, but carbon shows the property of catenation to a large extent than silicon. Why? Because carbon-carbon bonds are much stronger than silicon bonds. Why? Due to small size. Due to small size, carbon can hold shared pair of electron strongly. So, carbon bond is much stronger. So, the compound formed is exceptionally stable, carbon compounds, than silicon compounds. So, carbon shows the property of catenation to a larger extent. Okay.